Hello and welcome to a static fire of the second stage mock-up. This is on the reconstructed launch pad. Now, um, a while back, about a month ago, there was an incident at the launch pad with a first stage booster, which was being tested. And about halfway into its static fire, an issue with struts meant that it was able to freely wobble, which allowed some of the clamps to loosen enough to where it came free of the clamps control. And because of that, it flew away and destroyed much of the launch pad in an explosion. So we have reconstructed the main structure of the pad, which was destroyed mainly because at that time the counterweights which hold it up were not properly installed. We only install them once we're going to take the rocket out. Otherwise, those counterweights would just simply make the clamps slide against the side of the rocket as they get pushed down because of how much weight they're holding up. So now we have added some extra parts to make sure that nothing wears and tears with these tests. So we have these small walls that deflect flames. You can see them here. They go to the sides of each of these parts of the upper gantry, and they are able to disconnect from the lower gantry as well. You see them here, they look like an L shape. You can see from the sky the engine here. The engine we're testing is the second version of second stage engines. The specific name of the engine currently is Vac-01. We may possibly give a new name to them, but the current placeholder name is Vac-1, which just simply means vacuum engine number 1. So, according to this naming idea, the Vac-2 would be the next engine we make, but these are just simply the second version of these vacuum engines. So as you can see, there's some complex things with it, but the main thing was that we replaced some components with a singular tank, and many outside components have now been moved inside of the upper fueling structure, which you can see up here. Other than that, the struts themselves have been upgraded so that there are 2 layers of struts. So if you look here, you can see that there's struts coming from here and struts coming from here. So they're on the lower and upper gantries. So that's very important to make sure that no incidents like the one that happened to the booster on the previous static fire happen again. Now this mock-up here is a mock-up of a second stage. Currently working on getting a booster for the first ever pair, possibly a static fire with the pair of them, with a upgraded launch pad. This is just our static fire stand, because after what happened to the booster, we realized that our actual launch mount would have to be far more complex. And we've decided to construct a facility in a desert area in Arizona for testing these vehicles. So now if we pan over to the fueling view, this is on the portion of the gantry that includes fueling pipes and things of that sort, electrical connections, all of that. You can see, if we zoom in the camera, slight zoom here, you can see how that yellow line feels straight into the vehicle. We're expected to perform a static fire fairly soon. We've got a similar engine setup to the last static fire. It's just simply going to static fire once, stop, and then static fire again to stress the engine, fully test it, and we'll learn from any issues that occur with the engine whilst trying to maintain as safe of an environment as possible. So the environment is safe. So the rocket still has the possibility to have mishaps, but it's not like we're just gonna pretend like safety isn't a thing. Even if this is a test, we still want to act like this is a prototype that will fly. And we're just finishing up that last little bit of fueling right now. We're about a minute away from that go, no-go poll that'll finish up our pre-static fire operations. So these flame deflectors and the new struts are the main improvements to the pad. We've had an improvement to the engine. So you might remember the old vacuum engine from the first ever testing at this very site. That engine has been completely redone. We've already stated that. The fueling is nearly complete, and all of the GSE and infrastructure in the area has been rebuilt accordingly after what occurred on the previous static fire. You may ask what caused the explosion mid-air with that previous attempt. So what happened was, as it was going up, simply it was not built for flight, and it was also beginning to spin, and as it began to spin and it was exerting force, plus that weight simulator that was placed at the very top, heavily pressured, like lots and lots of weight was placed on that upper dome. It could not hold it. Boil-off gases had already built up significantly, and what happened next was a simple rupture of the upper tank, followed by a rupture of the lower tank caused by stress on the center dome, or common dome as it's called, that caused the propellants to mix and cause an explosion. The ignition source, of course, would just be simply the engine. So there were some small popping sounds. That was just simply some mishaps with electrical lines and the liquid fuel, followed by those big explosions, which was the actual ignition of the rocket fuel. And the engine was sadly lost as well. So no data to be learned from that static fire attempt, other than a failure mode. And currently that poll is still ongoing. There was some criteria that was not met, mainly with the clamps. Once again, clamps are the hardest part of this, because the clamps have heavy pressure applied, and the pressure in the system that presses against the rocket to hold it in place is taking some time to be readied. So we're just waiting for some high pressure air to be readied, and then we will simply run that high pressure air through the pipes that push really hard against the rocket there to hold it in place. Otherwise, when they turn on that engine, it just slides right out of the clamps. And I don't know if there's a good camera for it. Not really. I guess this is the best one. You can kind of see the connections there. There's 3 connections into the rocket. These are pressure points that basically they're on the side of the rocket. There's some small, I guess, appendages that extend out from the hull of the rocket. And basically, what these clamps do is they latch onto those appendages with a certain amount of pressure, and they make sure that it does not fly away from that pad. So that's pretty much what these clamps do. So they're very important. You can see that there's 6 of them, 1 for each of these towers. And then, of course, there's the quick disconnect, which fuels propellant in right there. So the struts are fine. The clamps are nearly good. We're just waiting just a little bit, and that'll be that. Okay. All right, and we heard that they have finished the issue, so they're gonna go again with the go no go poll right now. And there we go. All right, so we should see static fire very soon. So we'll begin with the engine startup, and then there will be the actual ignition of the engine. The process to start up this engine is slightly longer, as they need to feed the coolant lines right here, which takes a little bit longer. So we'll see startup happen about now. Yep. Just wait. It'll happen. Static fire is set for 5, 4, 3, 2, 1, go. See the static fire rumbling significantly. So there's a little bit of shake in the water tower. That's normal. It's extremely high power. We're going to see a shutdown. Yep, and there's the shutdown. You can see smoke beginning to clear. And basically what happens is those flame deflectors spit flames and smoke in 2 directions to make sure it does not damage any infrastructure. And so far, so good. No incidents with the engine. Nothing. The clamps are still holding pretty well. One of the struts is a little bit torn from that, but those flame deflector walls on the sides of it, those panels right here, are keeping those flames away from struts. So only one strut was partially damaged. A section of it was reported to have been cut just slightly by a fire that was put out by itself. So just waiting, standing by, making sure everything is fully nominal before we continue. So the backup strut is still there, so this thing's still fully clamped down. It's just that one of the struts out of 2 on one of these 6 strut connections is slightly damaged. So we're just waiting, make sure that that won't make it so this thing can't static fire for the second time. And there we go. So we'll hear any second now, it'll just go because it's already been started up. So we'll hear, there it goes. And hear it slightly. See this? This is from the upper gantry, looking down at the engine. You can see it. Next up, this is the fueling cam. You can see the smoke coming out of the flame deflector here and out of there. And this is going to be a pretty long test, so we'll just stick here and wait for that test to complete. It'll fully drain the vehicle of its fuels. So, yeah, we might have to wait just a little bit for that to happen. And there it goes. It's out of fuel, and the engine has been automatically turned off. So we are now just waiting to hear that all systems are ready to begin the detanking process of the. There's a couple little bits of fuel that would be residual or left over that did not cycle through the engine. Because if we do use up quite literally every single last drop of our fuel, that can actually cause problems. So we're just waiting before we detank. And they said that they're going to detank. So this test was a pretty long one. Pretty long. So it's good because it means that these engines can run for long periods of time. And I mean, this is still nothing like in-flight conditions, so we'll have to test these engines even more. Luckily, we have engine testing rigs at our new desert facility over in Arizona, so we should see some testing conducted there, and we may broadcast those, although those kind of broadcasts would likely not be commentated, just simple videos. So that's about it for today's testing campaign. We'll see, hopefully, a brand new booster constructed. We'll see its static fire, and hopefully they learn from their previous mistakes. And then after that, we'll see integration, a second static fire with the upper stage on top, just to kind of test how that would work out. And then that would be that. Alright. Well, that'll be it for today's testing campaign.